Hello, Dr. Maya Durna here. I am here with chapter 10 today. It's chemical reactions and chemical equations. This chapter, you will learn how to write the chemical reaction, the balancing equation, and types of chemical reactions. So, very first, the balancing chemical equations, very important. It's one of the basic things in chemistry. You know how to write the chemical equation, and then balance it. Basically, chemical equation is the written statement for chemical reaction. If you look at the this chemical reaction showing here, so this one, we usually write the chemical reaction in a form of equation. And this side you have ammonia NH3. We learn the nomenclature. Ammonia reacting with, this is an acid, binary acid, hydrochloric acid, reacting and form ammonium chloride. You have reactants react and generate products. So normally non-metals, they are like, usually they exist in um, polyatomic molecules. So let's take a simple example and see how we balance this equation. So this particular reaction, formation of water, and always when you write the reaction, you need to write the state. G is for gas, S is for solid, like the parenthesis you write in as like a subscript. G is for gas, L is for liquid, S is for solid. So in this particular reaction, first thing is you write the chemical reaction. So when you write the chemical reaction, let me see, it's not connected yet. Okay, yeah, it's there. So now our reaction is, yeah, here hydrogen. Yeah, so hydrogen gas combining with O2 gas forming H2O liquid. So now let's see, I told you these are reactants, these are products. Reactants react and generate products. So in order to balance, you see they have two hydrogens in the reactant, and so in balancing means number of atoms in the reactant side should equal to the number of atoms in the product side. You have two hydrogens in the reactant side, you have two hydrogens in the product side, so hydrogen is good. You have two oxygen, but how many oxygen you have? You have only one oxygen. You see, it is one oxygen this side. So in order to make it two, what are we going to do? We're going to put two in front of it. You can add as a subscript. You can take water and put two, then it's going to be a different compound. So you have to put two in front as a coefficient. So now you have put two in front of water. That two is relevant to the hydrogen and oxygen, but now you have two oxygen, but you have four hydrogen. Where's four? 2 into 2, 4. In order to balance, you put 2 here. So this is the balanced chemical equation. If it is 1, we usually don't put it. So that's how we balance simple equation. I'm going to take another one. This is another equation. This is, you don't know what to know. This is organic compound called butane. You don't know how to name it. It's butane reacting with oxygen form carbon dioxide and water. Let me take that as, so C4H10, our reaction. Let me take the color. C4H10. It's a gas reacting with oxygen gas, give you water, liquid and carbon dioxide gas. So now let's see how we're going to balance this equation. 4 carbon, 1 carbon. In order to make it 4, you put 4 in front of it. Then look at hydrogen. Hydrogen, how many? 10 hydrogens, but you have only 2 hydrogens. How to make it 10? 2 into 5. So you put 5 in front of it. And you count how many oxygen you have in this side. So you have 2 oxygens this side, but this have 5 plus 4 into 2, 8. You basically have 5 plus 8, 13 oxygen. But this is you have 2. So now, how do you make it? So you need to add more hydrogen to this side, oxygen to this side. How do we do it? You cannot add 13 because in that way it's going to be, let's add third. So it's going to be 13, 26, right? So what we're going to do? I'm going to add, if I add 13 here and 2, you multiply whole thing by 2, 10, then this 4 multiplied by 2, it's going to be 8. So now let's see our reaction back again. Let's rewrite it. 2C4H10 plus 13O2 give me 10H2O plus 8CO2. Now let's look at the number of atoms. 8 carbon, 20 hydrogen, see, and then oxygen, 13 into 2, 26. It's 10 and this is 10, right? Oxygen 10 and it's 26. Now it's balanced. So you see how we balance the equation. You have to balance number of atoms in the reactant side should equal to the number of atoms in the product side. So that's how we balance the equation. Let me take another example. So you can, so in here in your PowerPoint, it's the same thing. Then when we go to the oxygen, you can put the 13 divided by 2, but you can't have the fractions in the equation, so you multiply whole thing by 2. So that's the same thing they get. So now I have this question. Write the balanced chemical equation for the aqueous reaction of barium hydroxide and perchloric acid to produce aqueous barium perchlorate and water. First thing first, you need to know how to write the chemical equation. If you don't know how to write the chemical equation, then it's going to be a little tough, right? So how to write the chemical equation? Barium hydroxide. How do you write barium hydroxide? BaOH, barium hydroxide. But let me go to the book thing. Okay, so barium hydroxide is, let me go get a good paper. Barium hydroxide, Ba, hydroxide is OH. But barium is in the group 2, so it gives 2 plus, so it goes under 2 plus, I forgot what was it? Barium, okay, let's see. Barium, and then it's a perchloric acid. I don't know whether I can get it back. No. Okay, I can't get it. So barium hydroxide and the perchloric acid is HClO4. So let me write the reaction really fast. I forgot what is the two reactants. So barium hydroxide, perchloric acid HClO4 give you barium perchlorate O4 twice, and I think it's water. Now you have to balance this equation. I'm using another color. Barium 1, barium 1. I am good. But you have ClO2 here. ClO4 1. So you put 2 in front of it. And then count how many hydrogens. This side you have, in hydroxyl you have 2 hydrogens. This is 2 hydrogen, but this side you have only 2. You put 2 in front of it. So it's going to be 4. And then you look at oxygen. Oxygen 1, and 2. So because it's 2 relevant to the 2 outside of the parenthesis relevant to H and O. So it's 2, and then this you put 2 in front of water. This 2 relevant to belong to oxygen as well. So now we'll look at the equation again, the balance equation. Let me write the same thing again in another color. Pick another color. I like this pink. Okay. So barium hydroxide twice reacting with these lines, reacting with perchloric acid, HClO4. Give me barium perchlorate plus water. Then I have uh, 2 in front of it, 2 in front of it. So I have one barium, barium is good. 2 ClO4s, 2 ClO4, ClO4 is good. And then I look at hydrogen, I have 2 hydrogens here. I have 2 hydrogens here, 2 hydrogens here, 4 hydrogens. In order to make it's 2 into 2, 4, and 2 oxygen, the equation is balanced. So that's how I balance this equation. But this equation is has one step ahead. You need to know how to write the chemical formula of each reactant and product. So I have another problem. I think this is not a problem. Okay, let's do this one. So the butyric acid, also known to as this one, is one of the many compounds found in milk fat. First isolated from rancid butter, 1869. Butyric acid receive a lot of equations. Write the lot of information, but the important thing is it's write the balance equation for the metabolism of butyric acid. Assume that the overall process and metabolism and combustion are the same. Combustion means always reacting with oxygen. So I need to know butyric acid is C4H8O2. So I'm going to write C4H8O2 reacting with oxygen, producing CO2 and water. I'm balancing. I use another color to balance. I have 4 carbon. I put 4 carbon. I have 8 hydrogen. I put 4. Now it's become 8. And then count oxygen. I have 4 into 2, 8. And 4, 12. I already have 2 here. So it's gonna, I write 5 here. Now it's balanced. So if I balance it, 4 carbon, 4 carbon. 8 hydrogen, 8 hydrogen. 2 and 10, it's 12. 2, no, 4 into 2, 8 plus 4 is 12. So equation is balanced. So this one, they have given you what is the butyric acid, and then they ask you to the combustion, always combustion, give reacting with oxygen, producing carbon dioxide and water. You balance it. Okay, and then I have another question. I think that's balance. One we balance, and then that's how that's how you balance the equations. And then we are going to the type of the solubility rules. That's another important topic. The solubility rules showing you. So we learn so many compounds, right? Like sodium chloride, magnesium chloride, aluminum hydride. So whenever you dissolve these compounds, are they soluble in water or not? So the first thing to know is this is good. There's a one trick that you can know. If there are certain cations are positively charged ions present in the compound. Compound is for sure soluble whatever the anion is. Example of those cations, if your compound has sodium, potassium, rubidium, cesium and ammonium present in the compound, your compound is completely soluble. Example, sodium chloride, soluble. Sodium sulfate, soluble. Sodium perchlorate, soluble. Doesn't matter whichever the anion is. If it is sodium, if it is potassium, rubidium, cesium, it's soluble. Same with ammonium. Ammonium chloride, ammonium phosphate, ammonium oxide, it's soluble. Same way with the anion. Nitrate, this is acetate, chlorate. Any nitrate. You can easily think about nitrate. Go to the Walmart, you see the sausage and the processed meat. No nitrites, no nitrate. So nitrate is soluble. Any nitrate. It can be sodium nitrate, silver nitrate, Ammonium nitrate, aluminum nitrate, it's for sure soluble. That's the easiest thing to know. Any of these cation or anion compound is soluble. Now we are going to the next step. Our next step is if anion is chloride, bromide, iodide, then it is they say usually chloride, bromide, iodide soluble unless the cation is silver, mercury, lead. That means silver chloride, silver bromide, silver iodide insoluble. Mercury chloride, mercury bromide, mercury iodide insoluble. But if the chloride is with sodium chloride, if it is magnesium chloride, if it is zinc chloride, they are soluble. Sulfate, usually sulfates are not soluble. The anion is soluble. You say if the sulfate is there, if the cation is silver ion, the mercury ion, lead ion, it's so the compound is like example, it comes with the silver sulfate, lead mercury sulfate, calcium sulfate. So these things. So you see, silver mercury lead comes again. Usually silver mercury lead is insoluble, except it's with sodium, it's like nitrate, something like that. But if the sulfate comes with the silver, it's insoluble. Anything else like sodium sulfate, magnesium sulfate, potassium sulfate, they're soluble. And then another thing, these are basically insoluble: carbonate, phosphate, chromate, sulfite. They are insoluble, but if they comes with the soluble anions, what are their soluble cations like sodium carbonate, potassium carbonate, cesium carbonate, ammonium carbonate. So always if this comes with the sodium, so these things, any anion is soluble. Same rule applies for the hydroxide here. What do you think about magnesium hydroxide? It's insoluble. Why? Because it's not sodium, it's not potassium, like that. So that's how you should know what is the soluble. How do you know? That's how you predict whether your compound is soluble or not. I have separate video on solubility rules. Please watch that as well. But this summarize you. Okay, how do you predict the compound is soluble or not? And then you get silver nitrate. You don't have even to look at it because it's nitrate ion, for sure soluble. We look at potassium carbonate. It's potassium, right? When there's a potassium there, the compound is for sure soluble. So, and then calcium sulfate contain the sulfate ion. The sulfate ion is SO4 2 minus. The compound containing sulfate ions are soluble except for these. So calcium is not involved in this list. So it's a solid. So calcium, that's the calcium ion is one of the. Wait a minute. Calcium is in the list. So calcium sulfate is in the. It's not soluble, but if it is any compound with sulfate like sodium sulfate, potassium sulfate, then it's soluble. So that's this video. So summarizes the equation balancing and the solubility rules. Thank you.